So we're going to continue our trig stuff here with two more kind of vocab terms we're going to add to it called the angle of elevation and the angle of depression. Okay. So I have your guided note sheet here. This covers what we're going to talk about today, mainly because most of these are situational problems where we have to use trig functions to solve some situation. Okay. But first we have two vocab terms, the angle of elevation and the angle of depression. The correct term for the angle of elevation is, formal definition, the angle between the line of sight and the horizontal when looking upward. We're going to see what that looks like with a picture in just a second. Where the angle of depression, the angle between the line of sight and the horizontal when looking downward. Okay. So these are two angles we're going to add. We're still using sine, cosine, tangent, inverse in these problems. But we have two angle types when we're given some situation called the angle of elevation. Elevation goes up, right? And depression when you're going down. Okay, between the horizontal and either the line of sight up or down. We're going to see what that looks like in figures in just a second. Next are the three trig functions. It should say like sine of x, cosine of x, tangent of x. Just as a reminder, what is sine? Which are the two sides of sine stand for? What's the ratio? Good. Opposite over hypotenuse, so you can write that as just to refer to, just to remind yourself. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over adjacent. Remember the saying SOHCAHTOA, SOHCAHTOA. Also, the one I more often use, Oscar had a hold on Arthur, sine, cosine, tangent, OHAHOA. Okay. So we'll continue to use these. You will need to have those memorized at some point. But right now you have them at the top of your page there. Okay. So we're continuing to use these three trig functions. Then in that example there, it has this figure. And it says identify the angle of depression and the angle of elevation in the following figure. So the angle of elevation is from the horizontal upward. Okay. So this we call the angle of elevation. Because it's from the horizontal upward. It's that angle. The angle of depression is from the horizontal downward. Okay. So there I have angle of depression from the horizontal downward, the angle of elevation from the horizontal upward. There's only two angles in this figure anyway, but those are what those look like. Okay. Where it gets a little tricky is when you're given a situation, you have to draw a figure and it says either find the angle of elevation or this is the angle of depression, things like that. Okay. So this is the day you get to make fun of my drawing skills. I'm not very good. So, example 2 there at the bottom. It says this surveyor. So this guy, okay, we'll do the first one together. You have a surveyor, okay. He's standing 100 meters from a bridge. So from where he's at to this bridge, straight across, is 100 meters. In all of these figures, you're going to want to draw the picture out. And we'll call the bridge right here. This is my bridge. Okay. She determines that the angle of elevation to the top of the bridge is 35 degrees. Okay. Now the angle of elevation is from your line of sight horizontally upwards. So that means his angle of elevation, there's your horizontal, because it's from the line of sight horizontally upward to the top of the bridge. Does that make sense? That is 35 degrees.
But that whole like angle-ish thing?
The angle of elevation, it's from his line of sight, so he sees out his eyes, right? So his line of sight upwards is 35 degrees. Okay. And it says his eye level is 1.5 meters above the ground. So that means from here to here is 1.5 meters. Right? From the ground, so you know, here's my grass. So from the ground to his line of sight is 1.5 meters. I label it over here. The question is, find the height of the bridge. Well, the bridge goes from there to there. We'll call that X. So there's my figure. Okay. Remember, elevation goes from your line of sight, not from your feet, from your line of sight horizontally upwards. Okay, and they said that was 35. So first, let's just look at this right triangle I have here. I have a large right triangle here if I wanted to, but let's look at this one. Okay. I know that angle's 35. Well, I know from my eyes to the bridge is also, this piece is also how long? It's 100 because I'm standing straight up. So from my feet to the bridge to my eyes to the bridge is still 100, right? So I can call that 100 meters also. There's my right angle. I can find this piece because I have one leg of this triangle and I have the angle. What relationship is 100 to this angle? Opposite, adjacent, hypotenuse. It's adjacent. And what about this piece of the bridge? Opposite, right? But with respect to this angle, I have the opposite, or I'm looking for the opposite, and I have the adjacent. Right? Everybody agree with that? So which trig function do I want to use? Tangent, right? So if I take tangent of the angle, so tangent of 35, tangent of the angle, that's equal to opposite, which, let me give it a variable name because I haven't given that a variable name yet. Let's call this, I'll call it y. Opposite over adjacent. Tangent of 35 equals opposite over adjacent. The reason I called this y is because I'm only looking at this right triangle. So I'm only looking at the bridge from there up. Okay. So I need to solve this equation for y. So I have to get y by itself. I have to get rid of the division by 100. So the way I get rid of a division by 100 is I multiply both sides by 100. Multiply by 100 there, those cancel. Multiply by, 100 here. Remember, I like to write the 100 in front of the tangent because on some calculators, if you do tangent 35 times 100, you don't close parentheses, it's going to do tangent of 3,500. And that's not what you want. You want 100 times the tangent of 35. So on your calculator, if you do 100 times the tangent of 35, I think you get 70 if you round to one decimal place. Is that what we get? You might check that on your calculator just to make sure you're in the right mode or you're plugging it in right. But this isn't finished because the question asked me what's the total height of the bridge, right? So what is the total height of the bridge here? 71.5, right? Because from here to here, I called that y. I just found that as 70. But I'm 1.5 meters up here from the ground. So the total height of the bridge is going to be 71.5 meters. Just adding those two together. Next one says, from the top of a lighthouse. So I'm going to make this my lighthouse. From the top of a lighthouse, the angle of depression to a buoy is 25 degrees. Okay, so I'm going to draw out here. There's my buoy. Looks like a popsicle, but whatever. Okay, so there's my buoy, and then so the lighthouse or the water, whatever. There's the water. Okay. It says the angle of depression to this buoy is 25 degrees from the top of it. So if I go from the top down, okay, I want to know which angle is 25 degrees. So the question is it this angle or is it this angle that's 25 degrees? Now it says the angle of depression. So if you look at your definition, the angle of depression goes from the line of sight horizontally downwards, right? From the line of sight horizontally downwards. So that means it's going to be this, which did it say? What was it, 25 or 35? 25. This is your 25 degree angle. Because the angle of depression is from the horizontal downwards.
Well, I thought
Horizontal downwards. Huh?
Where's the line of sight?
The line of sight from the top of the lighthouse. So the line of sight, there's your horizontal line of sight.
Oh, from
Yeah. Yeah, because it says from the top of the lighthouse. So, here's the top of my lighthouse. Okay. It says the top of the lighthouse is 150 feet above sea level. So, the lighthouse is 150 feet. The question is, find the distance from the buoy to the foot of the lighthouse. So that's going to be from this buoy to the foot of the lighthouse, which I'll call X. I'm looking for X in this figure, from where that buoy sits to the foot of the lighthouse. Everybody agree with that picture so far? Now, there's two different ways I can go about solving this. Because I have a right triangle here, right? But I only know the 90-degree angle of this right triangle right now, right? One thing I could do, this is, it actually doesn't, I don't know which way is a more difficult way, depends on which way you look at it. One way you could do is you could make another right triangle here, right? You could do it this way. I'm not going to do it this way, but you could do it this way. There could be your other right triangle, and from here to here is the same distance as from here to here, right? So I could call this side X, there's my 90-degree angle, and I could use a trig function on this right triangle to solve for X. That'd be a perfectly good way to do it, right? X would be adjacent. This piece would also be 150, and I could use trig functions on this to solve for X. Let's say I wasn't going to do it that way. You could do it that way, but let's say I didn't. Let's say I want to use this right triangle, since I already have 150 and X labeled there. I need either this angle or this angle. I need one of the angles to be able to solve for this. Okay. But right here, what do we call these two angles? Anybody remember?
Corresponding.
They're not corresponding. The other C angle relationship starts with a C. No, they're not congruent. I guess the other one. Not consecutive. Yeah, they add up to 90, which we call complementary, right? This is a corner of a square right here. Okay? So these two angles are complementary, which means they add up to 90. So if this one's 25, this one has to be 65. That one's 65 degrees. So now on this right triangle, I can start using my trig functions. What relationship is X to the 65-degree angle? Opposite, adjacent, hypotenuse. Opposite. So that one's opposite, and 150 is adjacent. I know this side's the hypotenuse because it's opposite the 90-degree angle. So since I have the opposite and adjacent, that means the trig function I want to use is tangent. Yep. So I'm going to take tangent of the angle. It's always tangent of the angle. Tangent of 65 equals the opposite side, which was X, over the adjacent side, which was 150. So I want to solve this for X. I want to get rid of that division by 150 with the X. So to do that, I would multiply both sides by 150. I do that there. Those cancel. I multiply by 150 there. Okay. So on my calculator, I punch in 150 times the tangent of 65.
321.7.
Yep. Good. So 321 and 7/10 feet. It didn't say what to round to. I just picked one decimal place. Okay. So there's what X is. Now, one thing to keep in mind, if this would have been in like inches, this would be in inches. Okay. I want to keep my units the same. But they're both in feet, so they're in feet. Okay. I would have got the same thing had I used 25, had I used opposite and adjacent. If I would have did tangent of 25 equals 150 over X, like the other right triangle, we would have got the same thing. But that's how far that foot of the lighthouse is to that buoy. You may have your picture flipped around, like the other way, which is fine. My picture would look something like that. I know my water tower looks a lot like a buoy. Right? So there's your water tower. It says this 32. If you have it facing the other way, that's fine. Okay. But your water tower is 32.5 feet. The student's standing there. Okay. And 110 feet away is the foot of the water tower. and it says their line of sight's 6 feet from the ground. The question is, what is the angle of elevation? So I call that x. Remember, the angle of elevation goes from your line of sight upwards. So my line of sight upwards. I'm trying to solve for x in that figure. Okay. So I have one right triangle here. But in that right triangle, I don't have any piece of it yet. I'm missing x. Okay. I actually know this piece from here to here is also going to be 110. Right? From my eyes to the water tower is going to be the same as my feet to the water tower. So I can label this piece 110 feet of that right triangle. This piece of the right triangle, how can I find it?
That's 6 feet. So you just minus 6 feet.
Yeah, exactly. Because from the ground up's 32.5, and then from my line of sight, 6 feet here. So I just subtract 6 feet from this, right? Because that's going to be from here up. So that's going to be about 26.5 feet. So both of these are in feet, which is what I want. If one was in inches, I'd have to make it feet or vice versa. Okay. So now looking at this right triangle, I'm missing x. I have the opposite side of x, and I have the adjacent side of x, which again is tangent. Right? So I want to take tangent of the angle, the angle's x, is equal to the opposite over the adjacent. Both of those are in feet, so that's good. So I need to solve this for x. Okay. Now how I get rid of an x when it's with the tangent is what?
That should be the tangent negative.
Yep, the tangent to the negative 1, which we call tangent inverse. Okay? Because if you can think of it as if you take tangent inverse of that side, those cancel, which you also have to take tangent inverse of that side. So you're left with x equals. So on most of your calculators, you can do tangent inverse. The parentheses will come up, and then you do 26.5 divided by 110. Close the parentheses, hit enter. On some of your calculators where you can't see it all on the screen, you need to do 26.5 divided by 110 first, and then do the tangent inverse of that. And I think when you do that, tangent inverse of 26.5 divided by 110,
At 89.4. 3.5.
it should be about 13.5 degrees. So if you're not getting that, let me come check that. Last one here says a roofer props a ladder against a wall so the top of the ladder reaches a 30-foot roof. So there, I'll make this my ladder. If you have it going the other way, that's fine. There's my ladder. And it goes up against a wall. Which is 30 feet. The angle of elevation from the bottom of the ladder to the roof is 55 degrees. So that's straight across. From the bottom of the ladder to the roof is 55 degrees. How far is the ladder from the base of the wall? So here's the ladder, here's the base of the wall. We'll call that x. Everybody agree with that picture so far? I feel okay with that? My ladder propped up against a 30-foot wall. I'm trying to find how far it is from the base. I have a 55-degree angle. So looking at angle 55, this side would be the opposite adjacent hypotenuse. It'd be opposite. And again, x would be adjacent.
Will we ever use the other ones?
Oftentimes with angle of elevation and depression, oftentimes you're using tangent. Not always. They could give you the ladder and say find something else. But
Is there like some other things that like will have costs?
sine or cosine? It could. If I would have gave you the hypotenuse, you would have used sine or cosine. In these ones, it just happened to all be tangent. So I'm going to take tangent of my angle. Tangent of 55 equals opposite over adjacent. Okay. Now notice here in the first couple problems, the variable ended up in the numerator. In the last problem, the variable ended up as the angle over here with the trig function. And in this problem, the variable ended up in the denominator. Okay. We looked at these a little bit last time. To solve for that variable, I want to get rid of that division by x. I want to get rid of that division. So to do that, I would just multiply both sides by x. I multiply this side by x. Those will cancel. And I'm going to erase this a little bit. Multiply this side by x. Whatever I do to one side, I have to do to the other. So then I have x tangent of 55 equals 30. I'm going to go ahead and erase this. And then to solve for x, I need to get rid of this multiplication by tangent of 55. So I would then divide this side by tangent of 55 and divide this side by tangent of 55. So I'll be left with x equals 30 divided by tangent of 55. You'll notice one kind of little trick you can use. Whenever the variable's in the denominator like this, all you do is you switch out the tangent 55 and x to solve for it. But this is kind of showing all our work to get to that point. So on your calculator, you want to do 30 divided by tangent of 55 to get x equals 21 feet.